So welcome to this video, and we'll be going over October 2020 Edexcel mechanics. Let's go. So question 1, we have a rough plane. It is inclined to the horizontal at an angle alpha where tan alpha is equal to 3/4. We have a brick P of mass M is placed on the plane with the coefficient of friction between P and the plane is mu, and we have that brick P is in equilibrium and on the point of sliding down the plane. And so we've got brick P, we model it as a particle. We need to find in terms of M and G the magnitude of the normal reaction of the plane on brick P. So first things first, what I've drawn is I've drawn a little diagram here, and I've got the angle alpha to the horizontal. So we also know that with this brick P, okay, if I put the brick up here, making this little circle, we know it has mass M. So therefore, we can just draw a line going down here. So this would be mg newtons for the weight, and then we know that there's going to be friction. Now we know that it's on the point of moving down the plane. Okay, they tell us that in the question, which means that the friction will be going up the slope. Okay, and that's all because they tell us that it's on the point of moving down the plane. So friction is always going to be the opposing direction of motion. So friction will be going up the slope, and then obviously we have the normal reaction as well. That is always going to be perpendicular to the plane. In this case, it will go in this direction here, and this will be the normal reaction, and we'll call that our newtons, okay? So now we have everything we need to know, and then for that 1a, we need to find in terms of M and G the magnitude of the reaction on P. So we need to work out our R value here. So to do that, then what can we do? Well, therefore, we need to resolve forces in this direction, okay, in the same direction as the R, which means that we will need to work out our weight value in that same direction. So what do we know? Well, we know that this one here will have to be a sine alpha. So this will just be an angle alpha again. So therefore, we know that our R, our newtons, that must equal mg cosine alpha, okay? And then in the question, they tell us that tan alpha is 3/4. So again, if we know that tan alpha is 3/4, then we can work out what our sine alpha and our cosine alpha values are. So let's do that here quickly. Then right angle here, and we know that this is going to be a 3, that would be a 4, and that would be a 5. Therefore, we know that a sine alpha would be opposite over hypotenuse, so 3/5. And a cosine alpha would be adjacent over hypotenuse, which would be 4/5. Therefore, if we know the normal reaction is mg cosine alpha, therefore our R value, our normal reaction, would just be a 4/5 mg. And now for the 1b, we need to show that mu is equal to 3/4. So to show that mu is equal to 3/4, well then, what do we know about mu? Well, we know that the equation for friction is going to be friction is equal to a mu R, okay? So right now, we've already worked out what our R value is. We've worked out what our normal reaction is, and that is 4/5 mg. So now if we can work out the frictional force, we can just do the frictional force divided by the normal reaction, and that should give us our mu value of 3/4. So all we need to do is work out our frictional force. So how can we do that? Well, we can just resolve going down the slope, okay? So right now, we can just resolve in this direction here, going down the slope. So if we do that, therefore we would get a mg, okay? Because mg is in that direction. And now it would be angle of sine alpha, okay? Because mg is an angle of sine alpha from that slope. So it would be mg sine alpha, okay? And then resolving forces, so with the resultant force, in this case, that would just be an F. And again, because we're not moving yet, we're still in equilibrium, obviously ma would just be 0, so therefore we just get mg sine alpha is equal to F. And we know what sine alpha is because in our previous question we actually worked out the value for sine alpha. We know the value for sine alpha is 3/5. So therefore we know that our F value is going to be a 3/5 mg. So we worked out our F value. We know that our R value is a 4/5 mg. Well, we know that F is equal to a mu R, so that means that 3 over 5 mg, I'm going to write that as 3 mg over 5 is equal to a mu over 4 mg over 5. Therefore, a mu is simply going to be equal to a 3 mg over 5 divided by a 4 mg over 5, which is the same as saying times by a 5 over a 4 mg. And as you can see, a lot of things cancel out here. Our mg's cancel out, our 5 cancel out, and therefore we are just left with mu being 3 over 4. So for parts C and D, we have brick P is now removed from the plane and a much heavier brick Q is placed on the plane. The coefficient of friction between Q and the plane is also 3 over 4. Explain briefly why brick Q will remain at rest on the plane. So this type of question, if we have a much heavier brick on the plane, well, if you just look at the diagram we had, when we worked out the normal reaction, right, the only other force acting on the normal reaction was the weight, right? That's the only other thing. Therefore, if we have a larger or a bigger mass, right, means we'll have a bigger weight, which will then mean that our normal reaction will also increase. But it also tells us that our coefficient of friction stays the same. So therefore, because everything's still going to be balanced, it's just be all proportional with each other, right? So it will remain at rest because the force is acting on this new brick Q, okay? Everything is still balanced because the weight of Q will just be proportional to the new normal reaction, okay? If we increase the mass, or which it will increase the weight, the normal reaction will also increase proportionally to that as well. So that's why it will still remain at rest, because the normal reaction will just be in proportion to the new weight, and it will just still stay balanced, all because the coefficient of friction is still the same. And for part D, okay, we've got that the brick Q is now projected with speed 0.5 meters per second down a line of greatest slope of the plane. The brick Q is modeled as a particle, and then using this model, describe the motion of brick Q given a reason for your answer. So one thing here, because it's projected with the speed of 0.5 meters per second, okay, there is no additional force added. It's projected with that speed, therefore there's no additional force added, which means that it doesn't actually have any acceleration here. It's just going to travel with a constant speed. So that's something you can say for when you need to describe the motion. Just got to describe that the key thing is just going to move with constant speed. So for question 2, we have a particle P. It moves with acceleration 4i minus 5j meters per second at time t is equal to 0. It's moving with velocity minus 2i plus 2j meters per second. And we need to find the velocity at time t is equal to 2 seconds. This is a nice SUVAT question with vectors. So what do we know? Well, we know our S value is just S in this case because they haven't told us that, so we can leave that as S. Our U value, our initial velocity, they tell us at time t is equal to 0. It's moving with that velocity of minus 2i plus 2j. V, that's what we want to work out, so that can stay as V. We know A is a 4i minus a 5j, and we want to find the velocity out at 2 seconds, so therefore t is 2, okay? So now we've worked all this out. What do we know? Well, we know our V, A, and a T, and we want to work out U, so therefore we do the SUVAT equation of V is equal to U plus AT. Therefore, V is equal to a minus 2i plus 2j, and that is plus 2 times the 4i minus the 5j, so that would be a 2 times the 4i is an 8i, 2 times the minus 5j is a minus 10j. And then all we need to do now is just group up our i's, group up our j's. So V is equal to a minus 2i plus I, 8i, that is a 6i. And then a 2j minus a 10j, that is a minus 8j. And that is our answer for 2a. So for part B, we have that at time t is equal to 0, P passes through the origin O. And at time t is equal to capital T seconds, where capital T is greater than 0, the particle P passes through the point A. The position vector of A is a lambda I minus 4.5j meters relative to O. where lambda is a constant. We need to find the value of the t, okay, and then find the value of alpha. Okay, so a lot to digest in this question. Where do we start? So let's start by writing down our SUVAT equation first, similar to the last question. So for this one here, we have that our S. Now, we want to work out what that value of t is, okay? So at that value of t, we know that the position vector of A is a lambda I minus 4.5. So in this case, S would be lambda I minus a 4.5j, okay? Now our U, that would stay the same as a previous question. That would still be a minus 2I plus 2j. We don't need to worry about V because V is not here, so we'll leave V out. We know our A, that is the same as the previous question. Okay, that's still going to be a 4I minus a 5J. And then our T, that would be just a capital T, okay? Because that's what we want to work out. So we've got all this information. Well, now we can put this into the SUVAT equation of S is equal to a UT plus a half AT squared. And we can work that out, okay? So let's work this out now. So therefore we get a lambda I minus a 4.5j that is equal to a minus 2I plus 2jt, and then that would be a plus a half of acceleration, which is a 4I minus a 5j, and then times that by t squared, so just put a t squared here. Simplify this down, leave the lambda I minus 4.5j here. This would give me a minus 2ti plus a 2tj. And let's do this bit all in one go. So we get half times a 4i, which would give me a 2i. Then with the t squared, so that would be a plus 2t squared I. And then we get half times a minus 5, so that's a minus 5 over 2. I'll write the decimal, so that'd be a minus 2.5. Then we also times it by t squared, so that'd be a minus 2.5 t squared j. Okay, so now it's taking shape. Now at this stage, you may think, let's just move our I components on one side and move our j components on one side. But actually, in this type of question, it actually would probably be easier for us if we don't do that, okay? Because remember that right now we have two unknowns, right? We have the lambda and we have the t. So we want to get it into a situation where we're able to solve just one unknown. Now with this lambda I minus 4.5j, we can actually leave it on that left side and we can just equate the coefficients to that lambda I and that minus 4.5. And that's what we're going to do. So right now we're going to group all the components on the right side, just group all our i's together and all our j's on the right side, and then we're going to equate that to what's on the left side. So if we do that, we get a lambda I minus a 4.5j. Let's group our I components. That will be a 2t squared minus 2ti. And then for the j's, that will be a 2t minus a 2.5t squared. And then that's all going to be j. And now, as you can see, that 2t squared minus 2ti, that must equal the lambda I, and the 2t minus 2.5t squared j, that must equal the 4.5j. Therefore, now it's going to be a lot easier now equating this. And now we're at this stage, well, now we can just equate the coefficients together. As you can see, let's do the j components, that just has t's in it. Well, if we look at the j components, that must mean that a minus 4.5 must equal a 2t minus a 2.5t squared, okay? And if we've done that, well, now we can work out what the t value is, and then later we can work out what the lambda value is. So if we look at this is a nice quadratic equation. So if I just rewrite this, we get a 2.5t squared minus a 2t, okay, minus a 4.5, and that is equal to 0. So we've got a nice quadratic equation here. And at this stage, just put it into your calculator. I would say I wouldn't waste time trying to solve it by yourself. You can if you want to. But yeah, I would just put into a calculator and make it quick for yourself. And if you put into a calculator, you'll get two values. You will get t as being 9 over 5, and you get t as being 8 minus 1. So in this question, remember they said that t has to be greater than 0. And since t has to be greater than 0, we can just disregard this one here. And therefore, our answer is just going to be 9/5. So we worked out t now as 9/5. Now we need to work out lambda. But lambda is not that difficult, to be honest. If I just do lambda quickly down here, so look at our lambda value. Well, if we equate our I components together now, that would just be a lambda is equal to a 2t squared minus 2t. And we know what t is now. We just worked out t. Therefore, we know it's going to be a lambda is equal to a 2 times 9/5 squared. And then that's minus a 2 times 9/5. You put that all into your calculator, and what do you get? You get, as a fraction, 72/25, or as a decimal, you get a 2.88. So for question 3, we have a particle P, and it moves with the acceleration a meters per second, and it's given by this equation here. We are also told that at the instant when t is equal to 0, the velocity of P is 36 meters per second. We define the velocity of P when t is equal to 4. So this question is a variable acceleration question, okay? And since we've been given the acceleration, to work out the velocity, we will need to integrate. And they also tell us that when t is equal to 0, v value is equal to 36i. So that's how we can work out a constant as well. So if I just rewrite that down here, so we know that a is equal to a 1 minus 40i, and that's a plus a 3 minus a t squared j, okay? So we need to integrate this to look at the velocity. If we integrate everything here, then we get a v, because now we're dealing with the velocity. Integrate 1 minus 4t, well, that will be a t minus a 4t squared over 2. So that would be a 2t squared, okay? And that is all going to be, still going to be I. And then we do the same thing for the j's over here. So we're 3 minus t squared. If we integrate all of this, we get a 3t, and then we get a minus a t cubed over 3. And this is all still going to be j. And then that is still, we're going to have a plus c because we're integrating, we're going to have a constant value. Now in the question, because they tell us that when t is equal to 0, we're told that our velocity is 36i. We can use that now to work out our velocity. So if we do that, well, we know we're going to have a 36i here. And if t is 0, well, then our i's and both our j's as well, they will just both go to 0. So therefore, we're just left with c. So we know that 36i is equal to c. Therefore, if we know that, well, therefore, if we rewrite the equation now, we can just rewrite the equation as a v is equal to t minus a 2t squared I, and that's plus a 3t minus a t cubed over 3j, and then if we plus that c, that is now going to be a 36i. And then what we now need to do is we want to look at the velocity when it's at 4 seconds. So just put make 4 into t, and that'll give us our velocity. So we get a 4 minus a 2, 4 squared, and that's I. And then we get a 3 times a 4 minus a 4 cubed over 3, and that's a j, and then plus the 36i. Let's work all this out. So for our i's, we get a 4 minus a 4 squared, 16, times a 2, that's a minus 32, so we would get a minus 28i here. Then we get a 12, then we get a minus a 64 over 3, so we get a, if I do this, let's do the 12 here, that's a 12 minus a 64 over 3, j, and then we still have that 36i. So now let's work out the v components, okay? I mean, not the v components, the I components, put them together. So that would just be an 8i. And then for this one, we have 12 minus 64. Well, what is, if we think about writing 12 as a fraction over 3, that'll be 36 over 3. So it'll be 36 over 3 minus 64 over 3. And that gives me a minus do this one here. That will give me a minus 28 over 3j. So we worked out the velocity, 8I minus 28 over 3j. So for part B, we need to find the value of t at the instant when p is moving in a direction perpendicular to I. So if something is moving in a direction perpendicular to I, then what does that mean? That means if it's moving perpendicular to I, it must mean that it only has a j component. So if we consider like this is the, let me use this one here. If we consider that this is the j component, okay, it's moving perpendicular to I, so it's only moving in the j direction, so it's moving either this direction or this direction, right? Therefore, our I value will just simply be 0, okay? There is no I component. If it's moving perpendicular to I, there is no I component, therefore our I value must be 0, which means that it will be moving in some direction of a scalar to j. It will be moving in this direction, lambda j, okay? Because there's no I component, so it must be moving in some direction, lambda j. Now we know that when we're dealing with something which is moving in this direction, we look at the velocity, okay? So we did just work out the velocity, but we just need to look at the base velocity, okay? So what we're going to look at now is we're going to look at this equation here, okay? So this is the equation we care about, okay? This one here. So I'm going to rewrite that now. So I brought over our v equation, and what I'm going to do now with that 36i, I'm just going to group it with the other I components, okay? So we have a t minus a 2t squared plus a 36i, and then we have the 3t minus a t cubed over 3j. And what they tell us is, again, just looking at, because it's perpendicular to I, we know that it must be moving in some direction where it's just going to be lambda j, okay? Therefore, we know that lambda j must equal t minus a 2t plus 36i, and then plus a 3t minus a t cubed over 3j, okay? And therefore, if we know that, it becomes very easy to work out now, because we need to work out the t value, okay? So we're going to look at the t value. Well, then, if we have no I component, we know I is equal to 0. Therefore, we can just say that t squared, not t squared, t minus 2t squared plus 36 has to equal 0, because we have no I component, it has to equal 0. And that's a nice quadratic equation. If we rearrange that, we get a 2t squared minus t minus 36 is equal to 0. And again, feel free to work out if you want to, or just put it into your calculator to save time. If you put into your calculator, you'll get these two values here. You'll get t is equal to a 9 over 2, and you get t is equal to a negative 4, okay? Now remember that when dealing with time and also in the question, they say that t is greater than or equal to 0. Therefore, we know that our t value is 9 over 2, so we can just disregard the negative. And yeah, our t value is 9 over 2, and that's that question done. For the part 2, we have that at time t seconds, where t is greater than or equal to 0, a particle q moves so that its position vector r meters relative to a fixed origin is given by this equation here. We need to find the value of t at the instant when the speed of q is 5 meters. Okay, so again, they tell us the key word here is speed. So we know that we're going to have to do some type of Pythagoras' theorem. We're going to look at the magnitude in some form. So how can we do this question? Well, in this case, we know that our r, that is the same as our displacement. That's the same as, yeah, that's the same as like what we would usually consider our s value, okay? So we know that if we differentiate this r with respect to t, that will give us our velocity. And once we know our velocity, well, we can just do the magnitude of that. The magnitude will be our speed, and our speed must equal 5. And that should be able to help us work out what our t value is. So if I do that here, then let me, it was part 2. Let me rewrite the equation. So we have that. We know that r is equal to a t squared minus t I plus a 3tj. So let's differentiate this, because that will give us a velocity. So that will be a v is equal to a 2t minus 1 I plus A3J, okay? And we're told that the speed is 5. So if we do Pythagoras' theorem on all of this, we know that that must equal 5. So if we do that, we would get a 5 is equal to a 2t minus 1 squared plus a 3 squared, okay, and that is all going to be square rooted. So we know that this must hold true, okay, because it's the speed is 5. And if we work this out, well, we can bring that square root to the side. Therefore, we get a 25 is equal to a 2t minus 1 squared, and then that 3 squared will just be a plus 9. And now, as you can see, we can just work this out, and we should get a quadratic equation, and then we should be able to use that to solve and work out what t is. So if we do that, we get a 25 is equal to a 2t minus 1, so that will give me a 4t squared. Then we get a minus 2t minus another 2t, so that would be a minus 4t. Minus 1 times 1 is a positive 1, and then plus a 9. So therefore, we get a 25 is equal to a 4t squared minus 4t plus 10. And if we rearrange all of this, we get a 4t squared minus a 4t. Bring that 25 over. That would be 10 minus 25. So we get a minus 15. And that is equal to 0. And now again at this stage, you can put this into your calculator and you will get two values. You will get a t is equal to a 5 over 2. And you get t equaling a minus 3 over 2. And again, t has to be positive. Therefore, we just disregard the negative. Therefore, our answer is going to be when t is equal to a 5 over 2. So part 4, we have this ladder AB. It has a mass m and length 6a. Again, they tell us as a length 6a, which means that most likely we're going to have to use moments. We're told the end of the ladder is on the rough horizontal ground. So we're going to have friction on the ground at A. The ladder rests at a fixed smooth horizontal rail at the point C. So we're going to have a normal reaction at the point C. We're told that point C is at the vertical height 4a above the ground, as we can see in the diagram. We're told that it is inclined to the horizontal at angle alpha, where sine alpha is 4 over 5. Coefficient of friction is mu. It's modeled as a uniform rod. We show that the magnitude of the force exerted on the ladder by the rail at C is 9 mg over 25. So a lot of information to digest. So first things first, where do we begin? Well, let's begin with that value we want to work out, the normal reaction at C. So we know that at C, there's going to be a normal reaction here. Okay, this will be, let's call it RC newtons. That's what we want to work out. We're also told that, well, we're going to have a normal reaction at A as well. That's the ground. So that will be RA newtons. Also we have uniform rod, and we're going to have, so we're going to have the weight in the middle. So that will go down like this. And that will be mg newtons. And last, we have the friction we need to include. Now, for the friction, it has to go to the right, okay? The reason for that is because we're in equilibrium, so we need something balancing this RC force. Therefore, the friction has to go to the right to balance the RC force. So that is everything we need to, also our force is added to the diagram. And we want to work out the normal reaction at C, so this value here. Now, we know the length is 6a or between A and B, and we know that we also have that this length of 4a. Now, one thing with this question, we want to take moments, okay? But we don't have moments from A to C. We only have moments from A to B, okay? So how can we work this out? Well, what they actually want us to do in this question is they actually want us to use Pythagoras' theorem here. No, not Pythagoras' theorem. No, they want us to use SUVAT. They want you to use SUVAT in order to work this out. But before we use that, we need to get some values for our sine alpha, our cosine alpha, and our tan alpha. So in the question, they tell us here that our sine alpha is going to be a 4 over 5. So if we know sine alpha is going to be a 4 over 5, then this is unusual because usually they always tell us what tan alpha is. But in this case, since they tell us what our sine alpha is, then more than likely we're going to have to use just that sine alpha value. But to be on the safe side, let's just do a right angled triangle with those values. So we get opposite is here, that's a 4, hypotenuse is 5, we get a 3 down here. So we also know that our cosine alpha is 3 over 5 if we need to use it. So now we have all the information we need to know. So now let's look at this triangle here. Okay, let's look at just this triangle here. And let's see if we can work out a value between A and C. Because if we can work out a value, then we can just take moments, okay? So let's try working that out now. Okay, so now I've drawn a little triangle here. We've got the distance, the vertical distance, so we've got 4A, and then we want to work out the what the distance is from A to C, and I'll call that X. Now, why are we working this one out? Because we want to take moments, okay? They tell us in the question, they give us length, so we know that we probably need to take moments. But if we want to work out what RC is, well, right now we have too many unknowns, right? So if we can eliminate the unknowns at A, then we'll just be left with the unknown at C. So we want to take moments at A. So that's why we want to work out this distance of AC, because by working out that distance, we can then use that to take moments. So if we work out the distance AC, well, we can use SUVAT to work that out. So right now in this case, we have that 4A is the opposite, and we have that the X, or our line AC, that is going to be the hypotenuse. So from that, we know that we're going to be dealing with sine alpha is equal to the hypotenuse over, the opposite over hypotenuse, which means that sine alpha, which we're told in the question is 4 over 5, that's equal to the opposite, which would be 4A over X in this case. And then we can use that to work out what X is. So it will be a 4A divided by a 4 over 5. So X is equal to a 4A divided by a 4 over 5, which is the same as saying a 4A times a 5 over 4. Therefore, we know that that value there is simply going to be a 5A. So we now have worked out that line. We've worked out that this is now actually a distance of 5A. And now we can use that to work out our question, because now we know that the line AC is just going to be a 5A. Now we can take moments at A. And if we take moments at A, let me just bring this diagram down here. Okay, if we now just take moments at A, bring this all the way down here like this. Well, therefore, if we take moments, it will just be A, RC. Now, RC is already perpendicular to the slope, so don't need to worry about doing anything there. We can just times that now by the distance of AC, which we now know as 5A, and that will equal, in this case, we just have the mg operating. So if we make the mg perpendicular to the slope, okay, we know that if this is an angle, this will be an angle of sine alpha, so this will be an angle of alpha here. So know that it will be a mg cosine alpha, and that will just be times, now it's uniform. We know the whole length of AB is 6A, so that will just be a times by a 3A. And here we can work all this out now. So we have a 5A RC. We know that cosine alpha, as we worked out in the previous question, or the previous part, that was a 3 over 5 mg times by a 3A. We can cancel out the A's, so they cancel out. So we're left with a 5 RC is equal to a 3 over 5 mg times a 3, that is a 9 over 5 mg. And then we just have RC is now going to be equal to a 9 mg over 5, and that is divided by 5, so that's the same as saying times by 1 over 5, which makes RC equal to a 9 mg over 25. So for part B, we need to work out the value of mu, okay? So I've just redrawn the diagram here, got rid of the lengths because we don't need them anymore. And to work out mu, okay, well, what is the equation? The equation is F is equal to mu R. So, and be careful, this is RA, okay, just be careful of that. Therefore, if we work out our frictional force and we work out our reaction at A, we should be able to work out our value for mu. Okay, so two things to work out. And to do that, we're going to have to resolve by forces. Now, one thing to note is I've written that I've written what RC is because we worked out that, so I can just write RC as 9 mg over 25. And what we've got to think about is we've got to think about if we're resolving by forces, we need to work out our vertical and our horizontal components. Okay, so that's what we're going to work out here. And if we think about this, well, we've got some alternate angles here. This one would be an alpha, okay? Which makes this one, that would be a sine alpha, and then this one would be an alpha. Now, loads of ways you can think of doing that. I look at it as alternate angles because they're both angles to a horizontal, right? This one and this one, so they're both going to be the same. You can also we can know that this is going to be a sine alpha too, because if you think about this whole triangle here, we have a right angle here, okay? And if this is alpha, this will have to be a sine alpha. And then there's also another right angle forming like here and here. So then therefore it makes this one alpha as well. Loads of ways you can think about it, but ideally we've worked out the horizontal and vertical components for that 9 mg over 25. Okay, we've worked that out here. And now using that, we can actually work out what our frictional force is going to be. And one thing I'm going to do is I'm just going to write also down what our sine alpha values are, because we're probably going to need our sine alpha and cosine values later. So I'm going to write them down here. So from the previous question, we also know that sine alpha is equal to 4 over 5, which makes cosine alpha equal to 3 over 5. And now let's start resolving. So if we start with a frictional force, okay, if we resolve in the horizontal direction, we just get an F is equal to a 9 mg over 25 sine alpha, okay, because it's an angle of sine alpha here. So we get a sine alpha, and then we know that that must mean that F is equal to a 9 mg over 25 times by, we know sine alpha is 4 over 5. So if we work this out, we get that our frictional force is going to be a 36 mg over a 125. Okay, so that's our frictional force done. Now let's work out our normal reaction at A. So for normal reaction, we actually have three forces in the direction. We have obviously the RA, we have the mg, but we also have this 9 mg over 25 is also going to be in that direction as well. Okay, so therefore if we work that out down here, we get an R, and if we resolve by forces, we just get an RA. Okay, and that is going to be plus this value here, so the 9 mg over 25 cosine alpha. So that will be plus the 9 mg over 25 cosine alpha, and that must equal the mg. It's be a capital Mg. And if we work all this out, we get an RA. That's a 9 mg over 25 cosine alpha is 3 over 5. That's equal to an mg. And then if we do an RA, that is equal to a 27 mg over a 125. That's equal to mg. I'm just going to put my mg's as small now, just because I've already made it small anyway. Now we've got this. That means that RA is equal to an mg. Well, if we make mg as a fraction over 125, we get 125 mg over 125 minus a 27 mg over a 125. Therefore, we get that RA is equal to a 125 take away 97. We get a 98 mg over a 125. So we worked out that our RA value, our normal reaction at A, is 98 mg over 125. We worked out that our frictional force is a 36 mg over 25. Therefore, we know that F is equal to mu r. So we know that a 36 mg over a 125 is equal to a mu times by 98 mg over 125. Therefore, mu would just equal the 36 mg over a 125 divided by the 98 mg over 125, which is the same as timesing by 125 over a 98 mg. And as you can see, loads of things cancel out. The mg's cancel out, 125 cancel out. So we are left with mu equaling a 36 over 98. And this does cancel down. We can go down, divide both by 2, and we get an 18 over a 49. That does not cancel down anymore. Therefore, our mu value is 18 over 49. Okay, so last question, question 5, where it's a projectile motion question. We have a small ball projected with the speed u on top of a vertical cliff. We know that it's 25 meters above the point N on horizontal ground. It's projected at an angle 45 above the horizontal. Motion of the ball is moving freely under gravity. We show that u is equal to a 28. Okay, so I've drawn a little diagram here. We also know that this angle here is 45. Okay, and now we can use that to work out our u value. Okay, so if we think about how we're going to do this question, well, in order to work out what our u value is, what we can do is we can work out what our t value is when it hits the ground. We can work out the t, and that will be the same when it's horizontal and vertical. And by using that hopefully should be able to give us a value for u. So let's start with the horizontal. Let's call that h. Okay, so horizontal, and we're going in this direction here. Then what's our s value? Our s value, it's 100 meters. It travels 100 meters, so s is 100. U would just be a u. Now it doesn't matter in this case. We can use cos or sine because it's 45. It doesn't actually matter. But for the purpose of these videos and for any future projectile motion questions, we will consider it that because we're dealing with horizontal, we will just stick to cos 45. And then we have t as t, which we are going to work out now. We're going to get an equation for that. So therefore, we know that in horizontal motion, it's going to be s equal to ut. So 100 is equal to a u cos 45. Okay, u cos 45 t, and a cos 45 is just root 2 over 2. So therefore, we know that 100 is equal to a root 2 over 2 t. Okay, and then oh wait, no, don't forget the u t. And then now if we get an equation for just t, therefore we get that t is equal to, it will be 100 divided by root 2 over 2u. So that would be a 200 over what's happened here, over a root 2u. Okay, so we know that t is going to be 200 over root 2u, and we know that that must be the same time if we look at the vertical components of this as well. So vertical components. Now vertical components is much more important when it comes to your direction. Okay, so if we look at the vertical and we're considering the up as positive, okay, then what are our values going to be? So in this case, we have s. Now, be careful of this. S is going to be a minus 25. Now, why is it a minus 25? Because if you look at the diagram here, okay, we actually start at O. We start at this point here, O. This point is 25 meters above the horizontal ground. So the ball's going to go up and it's going to travel all the way down. But because we consider the upwards as a positive direction, it must mean that if we're going down, that is the negative. So it's actually going to be a minus 25. Just remember that. Our u value is going to be a u. Now again, we could use cos 45, but let's just keep it like as sine 45. We know our a value. Okay, a is usually going to be 9.8. In this case, because we are considering down as a negative direction, a is a minus 9.8. In this case, our t will have to be the same as the horizontal component. So therefore, we can say that our t is going to be a 200 over a root 2u. And now we can just work this out. And that should be able to solve it for us, because now we've gotten rid of our two unknowns. Before we had two unknowns, u and t. Now we just have one unknown, which is now just the u, and we can work this out. So we use a SUVAT equation of s is equal to ut plus a half at squared. So let's start inputting our values. So we get a minus 25 is equal to a u sine 45 times t. We know that t is in this case is going to be a 200 over a root 2u, and then we get a plus a half times 9.8, so that is a minus 4.9, and then we get that 200 over root 2u squared. I'm going to write it as a 200 over a root 2u times by 200 root 2u, and then I will work that out later. So now at this stage, we get a minus 25 is equal to a root 2, root 2 over 2u times by a 200 over a root 2u, because sine 45 is just root 2 over 2. And then for this one here, if we actually work this value out now, we get a 4.9. Then we get a 200 times a 200, so that's going to be a 4. Then we have 4 zeros, so 0, 0, 0, 0, so that's 40,000. And then we get a root 2u times root 2u, so that'll be a 2u squared. And then we get a minus 25. Now this one, we get a root 2u times by a 200, so we get a, make this a bit bigger, we get a 200 root 2u over a 2 root 2u. Okay, and this one we can simplify this down a bit. We get minus 4.9, get rid of that 2, so we get a 20,000 over a u squared. Okay. Now we can also simplify this side down as well. We can get rid of the root 2, get rid of the u's, and then 200 over 2, that's just 100. So we've simplified this down now. This will be a minus 25 is equal to 100. And then that's just a minus a 4.9. And then actually we have that 20,000. So let's actually start working out the 20,000. 4.9 times 20,000. What would that value be? That would be a 98,000 over u squared. Okay, so now it's starting to take a bit of shape. And now what we can do is we can bring that 100 to the side. So we get minus 125 is equal to a minus 98,000 over a u squared. And now, as you can see, a u squared would just be a minus 98,000 over a minus 125. And if you work out that value, you get a 784. And therefore, so u squared is equal to a 784, which means that if you square root both sides, we get that u is simply equal to 28. So for part B, we need to work out the greatest height of the ball above the horizontal ground NA. So we just need to work out, the highest point of where this ball travels. So to do that, we know that we're going to deal with the vertical direction, and we need to make our V 0, okay? So for this question, part B, we just need to make it where V is equal to 0. If we think about the SUVAT in this question, okay, now what would the SUVAT be? Well, we want to work out the distance, right? That's what we want to work out. So it will be S. Now our U, what our U value be? Our U will just be a U sine 45. We know that we want to make V 0, okay, because again, we want to work out the greatest height. So let's say it's like here, the greatest height, which means that once it gets to this height, it's going to have a velocity of 0, and then it's going to come all the way back down. So now V is 0 when it's at its greatest height. And again, remember, we're dealing with the vertical, with this being the positive direction. So our acceleration will be a negative 9.8. Okay. So now we've got our S value, our U value, our V value, and our A value. Therefore, we'll use the SUVAT equation of V squared is equal to a U squared plus 2AS. And we know that from our previous question, we worked out what U is. U is 28. Therefore, we can just put that value in now. So we're going to have a 0 is equal to A. Now, so U sine 45. So it's going to be a 28 sine 45, and it's going to be all of that squared, okay? And that'll be plus 2 times a minus 9.8, so that'll just be a minus 19.6 s. Now we know what sine 45 is. We know sine 45 is root 2 over 2, so we can just change this to make it 28 times root 2 over 2, and then that'll be all squared minus the 19.6 s. So therefore we get 0 is equal to, well, that'll be a 14 root 2 squared minus a 19.6 s. Let's bring that 19.6 s to the other side, so it's positive. And now we have this 14 root 2 squared. Well, what is 14 root 2 times 14 root 2? Well, what would that be? Well, if we do a 14 times a 14, what do we get? Well, if you do a 14 times a 14, that is a 196. A root 2 times a 2 is a 2, so it's just 196 times 2. That gives me 392, so we know that 19.6 s is equal to 392, and therefore s is just going to be 392 divided by 19.6. That gives us 20. So we get s is equal to 20, but we are not done yet. So it wants to find the greatest height. Now, if we go back to the question, it wants us to find the greatest height above the horizontal ground and A. So above the horizontal ground and A. So we know that if this is NA, okay, we know that this is NA here. Well, we know that we already start 25 meters above the ground. So when we get S is equal to 20, then it's going to be the 25 plus the 20, okay? Therefore, our answer, we just have to plus 25 to our answer. So we get a 20 plus the 25. So our actual answer is going to be a 45 meters, because it's 45 meters above the horizontal ground NA. So for part C, we have that in a refinement of the model of the motion of the ball from O to A, the effect of air resistance is included. This refined model is used to find a new value of U. How will this new value of U compare with 28, the value given in part A? So the value of this new U value, okay, it would actually be greater than the 28 because it has to overcome the air resistance. If it gets to the same distance as in the previous, as before when it was the previous U value, then it has to be faster because it has to overcome the air resistance in order to get to those same points. Therefore, the new value of U will be greater than the 28 because it has to overcome the air resistance. And then for part D, we need to state one further refinement of the model that would make this model more realistic. Loads of things you can say. These come up every single time. You can say something like the size and dimension of the ball should also be included to make it more realistic. Okay, but that is this paper done. Overall, I'd say a very nice paper. But yeah, that'll be it for this mechanics series. I've got all the other videos of the Edexcel mechanics from 2020 to 2024. So if you want to check any of those out, feel free to check them out. But yeah, I hope you enjoyed this, and I will see you soon.